Okay, so this next section is about the cardiac cycle. And basically what the cardiac cycle boils down to is they take everything that's going on in your heart, so all the events associated with one heartbeat, and they kind of group it all together and they call it the cardiac cycle. Now in your book, there's a couple charts. So one chart is 19.21, and it has the phases of the cardiac cycle. And then there's a whole page on page 764 that summarizes everything. It's kind of overwhelming, so we're going to break it down a little bit. Okay, now, what really drives the movement of blood through the heart is pressure changes. Okay, so when you think about when you contract a chamber or you squeeze a balloon, the pressure inside that balloon or inside that chamber is going to increase. Now these pressure changes are what's going to make the blood flow through the heart, and it's also going to open and close the valves. Okay, now in order to measure pressure, we use a blood pressure cuff. Okay, but the technical word for it is sphygmomanometer. Okay, so sphygmomanometer, and that's basically a blood pressure cuff. Now, the units that we use to measure blood pressure are millimeters, and Hg is mercury. Okay, so we use millimeters of mercury to do that. So it's just like barometric pressure. That's what they use, is millimeters of mercury. Okay, now, when you think about how your blood is going to flow through your heart, there are some opposing pressures. Okay, so there are things working against the blood leaving the heart. So the great vessels, so the aorta, the pulmonary trunk, they have positive blood pressure. Okay, so their pressure is going to be high. Okay, what's in the ventricles has to go above this in order for the blood to leave. Okay, now the book shows this little picture, and I think this is kind of logical, the relationship between volume and pressure. So as volume increases, okay, so you take the syringe and you increase the volume of it, the pressure inside there is going to go down, it's going to decrease. Okay, so there's an inverse relationship between volume and pressure. Okay, so it's inverse. Okay, now if the volume goes down, okay, so you make the space in the syringe smaller, the pressure is going to go up. So inverse relationship. Okay, now when we start talking about the phases, we're going to start with quiescent. So quiescent is kind of like the calm. So in the quiescent stage, so this is stage number 1, all the chambers are relaxed, the AV valve is open, okay, and you can picture the blood is just pouring into the ventricles. Okay, now what's going to happen next is the atria are going to contract. So we'll have atrial systole. So in order for this to happen, the SA node has to fire, the atria contract. Okay, the P wave is going to appear on the ECG. The atria contract, the blood's going to go into the ventricles. Okay, now here's a vocabulary term. Okay, so at this point in time, the ventricles are going to contain what we call the end diastolic volume, or EDV. So the EDV is the amount of blood that's in there after relaxation. Okay, so end diastolic volume, so EDV. There's another table here that we'll look at. Okay, now, the next big step, so 3, this will be the third thing that happens, is isovolumetric contraction of the ventricles. Okay, so here's what's going on during this step. And I want you to think about this because you guys can figure this out without me. Okay, so iso is equal, and volumetric is volume, right? So the volume is not going to change at this stage. So the volume is going to stay the same. Okay, so here's what's all happening. Okay, so the atria repolarize and relax. The ventricles depolarize. Okay, the QRS is going to appear in the ECG, and the ventricles will contract. Okay, when the ventricles are going to contract, the pressure is going to go up, and the AV valves will close. When the AV valves close, that's when you hear lub. Okay, that's S1. Okay, the blood isn't ejected yet. Okay, so isovolumetric, it's equal. Okay, now stage 4 is ventricular ejection. All right, so ejecting. Okay, what's happening with ejection, right? Stuff is coming out. All right, so what happens is as the pressure goes up, the semilunar valves are going to open, and the blood is going to get ejected. Okay, what happens then is the blood volume in the ventricles is going to go down, so the pressure is going to decrease. Okay, so here's an important vocabulary term, stroke volume. Okay, so your stroke volume is the amount of blood that your heart ejects. Okay, normally at rest, it's about 70 milliliters. Okay, so you pump out 70 milliliters. So stroke volume, you need to know that. Okay, now, you can figure out how much you're actually pumping out, like a fraction of what you're pumping out. So it's called the ejection fraction. So what you do is you take the stroke volume and you divide it by end diastolic volume. So you're taking how much you're pumping and you're dividing it by your total amount. And what you get, so at rest, a normal person, it's about 54%. Okay, if you're exercising and your heart's really pumping, it can be as high as 90%. Okay, if somebody has heart disease, their stroke volume, their ejection fraction is going to be low. Their stroke volume is going to be low, so it's less than 50%. Okay, now there's a name. We don't pump all the blood out of our heart every time we pump it. Okay, so some blood stays in the heart, and that's called the end systolic volume. So that's the amount left in the heart after ventricular systole. Okay, now, next step, isovolumetric relaxation. Okay, so on here, the T wave is going to appear in the ECG. So the T wave is when the ventricles repolarize and they're going to relax. Okay, the semilunar valves close, so you get the dub, or the dub. Okay, don't worry about this. You can cross that out. Okay, the AV valves stay closed, and the ventricles, the volume expands, but no blood comes in. Okay, so volume is not changing. So it kind of makes sense, right? Isovolumetric relaxation. Okay, now that's going to take us to the next step. Okay, the next step is when the ventricles fill. And they divide it into 3 phases. Okay, so the way that the ventricles fill is the first thing that happens is when you open the AV valves, the blood just pours in to the ventricles. Okay, then diastasis is just the pressure stays low, but blood just keeps kind of draining into the ventricles. And then the atria contract. Okay, so then when the atria contract, that squeezes the last bit in. Okay, sometimes you can hear a third heart sound when the ventricles fill because it's the blood hitting the walls of the ventricles. so they call it S3. Okay, so I hope that makes sense. Now, it's written out in your book. I think they might start at a different place, but it's a cycle. So the cycle is just going to keep going on and on and on with every heartbeat. And it's all labeled in your book, so you can kind of see what's going on. I'll have some multiple choice questions about it. Like, I want you to get the idea of what's going on. But I'm not going to like make you write it out or anything. Okay, so didn't this make you want to cry? Okay, so this is what's going on in there's a picture of it in page, what is it, 364 or 764. Okay, I'm not going to give you this. There's just so much information on it. It's hard to figure out what's going on. But what they're trying to show you is that, okay, so here is a heartbeat or a second. Okay, and what's happening, here's what's going on with the pressure is up here. Here's what's going on with the volume is here. Here's what's happening with your ECG. And then here's what's happening with the heart. And they try to overlap it so you can see it all at the same time. But it's a little, to me, this is very overwhelming to look at. I mean, this graph has got like 5 lines on it. I just want you to get the idea that it's pretty complex and that it all overlaps, and you can kind of predict what's happening from where. But I won't give you this to do anything with. Okay, so this is that same picture again. So it shows how the blood is pumping and the contractions. So I think we're okay with that. Okay, now here's the volume changes. So you should be familiar with these terms. So end systolic volume is ESV, so that's after contraction. So this is what's left in there, what's left in ventricles. So you're starting out with 60 milliliters in there. Okay, when you have like this passive filling, you're going to add 30 milliliters, and then when the atria contract, you add 40 milliliters. So at the end of diastole, your ventricles each will have 130 milliliters in them. Okay, then your heart contracts. Okay, so ventricular systole, you eject 70, which is the stroke volume. Okay, and then you're back to the 60. Okay, now it's really, really important that both ventricles are ejecting the same amount of blood at the same time. So you should be in homeostasis there. So you should be ejecting the same amount from each ventricle. If not, then you get out of balance. Okay, so if you have unbalanced ventricular output, what can happen is it's congestive heart failure, essentially. So congestive heart failure. That's supposed to be an A. Okay, so if you look at this, okay, so if we're going right, lungs, left, okay, so what happens if the right side is working better than the left side of the heart, the fluid will actually build up in the lungs. Okay, and you get pulmonary edema. Okay, so you're getting more blood pumping out of the right side into the lungs than you are getting it to the body. So this is higher. So you end up with excess of fluid in the lungs. So that's a symptom of congestive heart failure, and it's pulmonary edema. So edema is anytime you have fluid accumulate in the tissue. So edema, fluid in tissue. Okay, and it can happen on the other side. So if it happens on the other side, okay, so the right side's working. Well, the right side can't keep up. Okay, so the right side is not working. So the right side's not working, but the left side is. So you're getting an increase of blood to the body, okay, and you're getting less blood to the lungs. So you're out of balance. So what happens is you end up with edema in the extremities. So fluid accumulates like in your legs, in your fingers. So that's not good either. It can accumulate around your organs too. So internally. All right, now let's see. I don't know how long I've been recording. Shoot. So I'm gonna stop here so that I don't make it too long.